DWM, a minimalist tiling Windows manager. Agenda: Windows Management Models. DWM History. Why DWM? Compile Configure Lifecycle. Getting started. Basic workflow. Tags and patches. Window management. A window manager decides how application windows are arranged, resized, and switched between on your screen. If arranging windows takes constant manual dragging and resizing, that overhead adds up across an entire day of work. Almost every desktop environment includes a Windows manager, even if most users never think about it directly. Any user working with many terminals or editors side by side benefits from Windows arranged automatically and predictably. Manually dragging and resizing every window every time you open one doesn't scale across a full workday. Floating and tiling Windows managers. A floating Windows manager lets windows overlap freely, positioned and resized by hand, like the desktop most people grow up using. DWM instead tiles windows automatically into non-overlapping regions, arranged by a layout algorithm rather than manual dragging. Floating Windows, macOS, GNOME, ADE Plasma, manual drag and resize. Tiling DWM, i3, BSPWM. Automatic layout algorithm. Problems with floating window management. Single point of friction. Every new window needs manual positioning and resizing to avoid overlapping others. Screen space is easy to waste with overlapping or oddly sized windows. Switching between many open windows often means hunting through a taskbar or alt-tabbing repeatedly. Keyboard-only workflows are harder when a Windows manager assumes mouse-driven dragging. Consistent window arrangement across sessions requires manually rebuilding the same layout each time. Misses out on the predictability of a layout that arranges every window the same way every time. The DWM system. Every open window is automatically placed into a tiling layout, filling the screen without manual positioning. Windows are grouped by tags rather than traditional desktops, and a window can belong to more than one tag at once. Configuration lives directly in the C source code's config.h file, compiled into the binary rather than read at runtime. Other tools in the same Suckless family: ST, a minimal terminal emulator; dmenu, a minimal application launcher; and Surf, a minimal web browser. DWM advantages. Automatic tiling means windows are always arranged without manual dragging or resizing. An extremely small code base, around 2000 lines of C, is easy to read in full and reason about. Tags offer a more flexible model than fixed desktops, since a window can belong to several tags at once. Keyboard driven by design, keeping your hands on the keyboard instead of reaching for a mouse. Compiling configuration directly into the binary keeps runtime overhead and complexity minimal. A long-standing community shares patches that extend DWM without bloating its core. Everything is compiled in C, almost. Is compiled in almost. One huge benefit of this design is that in DWM, almost every setting lives directly in the C source, not a separate config file. Changing a key binding or color means editing config.h and recompiling rather than reloading a runtime configuration. This keeps DWM's core simple, since there's no configuration file parser to write or maintain. New behavior is typically added as a patch or diff applied to the source rather than a plugin loaded at runtime. The trade-off is deliberate, a small recompiled step in exchange for a genuinely minimal auditable codebase. Tags and layouts. Tags. Flexible groupings a window can belong to instead of one fixed desktop. Layout. An algorithm that arranges all visible windows automatically. Config.h key bindings. Key bindings are declared directly in config.h as a plain C array. Applying a patch. Community patches are downloaded as diffs and applied directly to the source. History created by Anselm R. Gabb and first released in 2006, growing out of ideas from an earlier window manager called WMII. Became a flagship project of Suckless.org, a group focused on simple, minimal, and highly readable software. Deliberately kept its own source code size, treating a small, readable codebase as a feature rather than a limitation. The patch-based extension model grew into a large community archive of drop-in diffs for common feature requests. Remains actively maintained and widely used among users who value minimalism and full understanding of their own tools. Why DWM? Minimal, a tiny, fully readable code base you can audit in an afternoon. Fast, extremely low resource usage compared to full desktop environments. Predictable, automatic tiling arranges windows the same way every time. Keyboard driven, designed around efficient keyboard only workflows. Customizable, patches let you add exactly the features you want, nothing more. Backed by a long-standing community around the broader Suckless philosophy. Config.h. Config.h is the single file where nearly all of DWM's behavior and appearance are declared. Defines key bindings, tags, layouts, colors, and rules for how specific applications should be tiled. A fresh copy is generated from config.dev.h the first time you build DWM from source. Never expect config.h changes to take effect without recompiling. DWM has no runtime configuration reload. DWM compile configure lifecycle. Edit config.h, patch apply diffs, make compile, make install. Config.h is edited, optional patches are applied to the source, the whole thing is compiled with make and the resulting binary is installed. Getting started with DWM. This leads us to the three steps that get DWM built and running. Clone the source. Download DWM's source code from suckless.org. Edit config.h. Adjust key bindings, tags, and layouts to your preference. Compile and install. Compile DWM and install it as your Windows Manager. Basic workflow, editing, patching, and recompiling. Some call edit, patch, and recompile DWM's everyday loop. Every configuration change is a small, deliberate edit to a file you can read in full. Patches are applied selectively, so your build only includes the features you actually choose. Recompiling is fast since the entire codebase is small enough to build in seconds. Reading the source directly is often faster than searching documentation for how a feature works. Supports many workflows, development environments, keyboard-centric setups, minimal Linux installs. Works the same across any Linux or BSD system with Xlib available. Any questions? Thank you.